Hi everyone, Pierrick from Picaut Design here. This is the very last video of this tutorial series. In this one we will do the final render, the compositing, and convert this to a video. Let's get started. We will keep the compositing pretty simple, but I'd like to be able to use the emissive pass. So I will switch the color depth to 16-bit so that we will have more color information, and in the render passes I will just activate the emission passes. The idea is to be able to separate the LED and add a little bloom effect to it. From there, since we have already set up our samples to 256, I will just press F12 to launch the render. If you have a decent GPU, it should take just a few minutes. Once the render will be done, I will close the rendering tab and I will open a compositing tab instead of the 3D view. To activate the nodes in the compositor, you have to click Use Nodes, and then I will open the image editor instead of the shader editor. Since we have activated the Node Wrangler add-on in a previous video, I will Ctrl-Shift-click the render layer. This will automatically open a viewer node and plug in the image setup. Then I just need to load the viewer node into the image editor to see the image it's outputting. We could also display the picture in the backdrop of the compositor, but I think it's not a good idea because you get your node on top of your picture and it's very hard to work this way. First thing I want to create is the bloom effect on the LED. To do so, we will have to mix our base render with the emission pass, isolating the LED and blurring it. To do so, we will separate the red LED from the green screen using a converter, separate RGB. We will plug in our emission pass, and if you Ctrl-Shift-click it several times, you will be able to display the different color channel. Since our LED is red, we will be using the red channel, and to isolate it, we will use a converter matte node. Setting it to greater than will allow us to isolate the red channel based on the intensity of the LED. It seems the value of 0.67 is enough. Now I will add a filter blur. You don't need to plug it right away and just don't care about the connection I've done, they are wrong. What we need to do now is to isolate our LED. So we will be using the mix RGB here, and we will use the emission as an input, and we will mix its color with a black color. And as a factor, we will be using the mask we have generated with the matte node. This way, when the mask is black, the mix RGB will output a black color, and wherever it's white, it will output the emission color. Since we have just made the red LED white in the mask, it's the only thing that will appear. Then I can plug this into the filter blur, increase or decrease the value of the blur, and this will create for me some kind of bloom effect that I will be able to add onto my original picture. One important thing is to use the relative aspect ratio, so that whatever the resolution of the picture you are rendering, the blur size on screen will be the same. And I'm mixing my original image with the emission we have modified. I always like to add a bit of glare, so it's kind of a more natural and effective bloom to my scene. So I will add a filter glare. I will set it to fog glow. I will keep the threshold or light value to 1. Then when you move the mix value to -1, you will see your original picture. Moving it to 1, you will see the full fog glow effect. And letting it to 0, you will see your fog effect onto your original picture. This adds a subtle overexposure to your picture. Then what I generally do is to contrast a bit my picture. So in our case, it's gonna be pretty subtle because it's pretty balanced already. I will add a color RGB curve and I will give it a slight S shape. From left to right, the curve will read the color value of your picture, and whenever you are pulling this value down, you will make it darker, and whenever you add a point and pull it up, you will make those values lighter. So here I've slightly darkened the darkest color of my picture and slightly lightened the mid colors of my picture. Now one last thing I'd like to add to this picture is a slight vignette effect that will help focusing on the main character in the middle. To do so, I will add a matte elliptic mask and I will set its value so that it covers most of the picture. As usual, to see what you are working on, just Ctrl-Shift-click the current node. To get a feathery look, I will add a filter Gaussian blur and I will set it to relative and input a pretty high value. Don't forget to Ctrl-Shift-click to see its result. Then I will add a mix RGB node that will allow me to multiply the mask onto our previously created picture. And in between, to control the color of the vignette, I will add a color ramp. The idea is instead of using a pure black color, I will add a tint to it to make the picture colder or warmer at your taste. It can be very long to properly composite a picture, and since perfection doesn't exist, we always spend a lot of time trying to find the right balance and find the right mood we want. To be able to save our picture, I will add a new node output file output. I will plug in my compositing mixture, and when I open the property panel, I will be able to name those pictures, save them in the folder I want, and choose whatever format I need. I will name my picture Game Boy, switch to a PNG format at 16-bit, and whenever you will render a picture, it will be saved with the name Game Boy and as a suffix the frame number. At this time, you should launch a test render and see if your picture is correctly saved, and once you are okay with that, just press Ctrl F12 so that you will launch the render for the whole animation. This way the whole animation will be saved as a PNG sequence, which is better than exporting directly your animation as a video render. You will generally get a better result, and if the render crashes, you will lose only the picture that was being rendered, not the whole sequence. Once every frame has been rendered and we want to convert them to a video sequence, we will open a new instance of Blender, open the sequence editor, press Shift A and add an image sequence. There you will load all the pictures you have rendered. I will set the animation range of my document from frame 0 to frame 96, and I will offset this video stripe of 1 frame so that it starts at frame 0 and ends at frame 96. From there, if I press F12, Blender will render the frame we are currently reading. From there we can choose where we want to save our movie. In the Properties panel, in the File format, I will go to Output, select the desktop for example, and name it GB like Game Boy. Then I will change the file format to MPEG 4 video, and you can set the quality to perceptual lossless. Then you just have to press Ctrl F12 or go to render animation, and Blender will be converting this image sequence to an MP4 video. As usual, every render takes a bit of time, but here it won't take that much, so in a few minutes you will be able to read your video. Congratulations if you were able to follow this tutorial until this very last step. This is the end of the course. I hope you've enjoyed it. If so, please give it a like and don't hesitate to share it with your friends. I will see you in the next video. Cheers!